All right. I found this video on the internet just now. What I was looking for was not so much the troubleshooting of the low ice production like they're there. It's more along the lines of explaining how this ice maker works. That I did put a couple of videos out on the Whirlpool ice machine. I went over the manual and then we did a complete tear down of that ice machine. So and we do have some people that are starting to work on refrigeration and ice machines now. So I'm gonna do this one, and then once we're done with this one, I'm gonna set up some lectures on what we call the U-line ice maker, which is a little bit different. The Whirlpool one had a flat stainless steel plate that the water flowed down, and that's actually what we call the evaporator. The evaporator is what gets cold and produces the ice, okay? What's unique about the Scottsman is the Scottsman actually works like a water fountain. It has jets that shoot the water up into the evaporator, and the evaporator is upside down. Like when you want to make ice, you got those plastic trays, and you'd fill them with water, and you'd stick them in the freezer. When you're done, you twist it, and the ice comes out. Well, just imagine taking that plastic tray and flipping it upside down and spraying the water up into the tray. Now the thing is just like a refrigerator evaporator, the temperature's so cold, as the water's hitting it, the water starts to cool down. And once it gets cold enough, it sticks to that evaporator and builds up. And it makes like a bullet-shaped cube, and then it falls out. So first, I just want you to see this video. It's only 2 minutes long, but in the video, the guy's talking about problems he found with it. And then I want you to see like the actual how the water sprays up in there, because I don't have this ice maker here connected to any water for you to see. But when we reconnect it back, if you want to go in and look at it, we're going to hook it up at the end and we're going to produce ice tonight. You can actually see how it functions and everything. So take a minute, let's just watch this.
Scottsman Ice Maker. It's a DCE 33A ice maker. The customer complaint was it's not supposed to drop.
Faster, just a little bit.
You open it up on the inside here. When I first got here, this tube down on the bottom was off. It wouldn't stay connected. The customer also complained to that it was not working, that wouldn't stay on, and it wasn't pushed down all the way. So I came back and pushed it down all the way. So the next thing was to make sure we had a good solid spray, and we do. Got what looks like, when you look up in there, kind of hard to see with a cell phone camera.
Okay, so this is what I wanted you to see. First of all, that plastic sheet that he lifted up, the water's shooting up from these two, like a water fountain, spraying it up, or your sprinkler in your yard, it's spraying it up. The evaporator is up above this plate facing down. And we'll take a look, I'll get the camera on this, the one that we have here. The plastic sheet is hanging here so that any water that doesn't stick to the evaporator drips back down into this reservoir that's below here. And if we go back just a little bit here, let me see here. Right here, you can see that this triangular piece here is the reservoir. So the machine fills up with water, and then that container holds the water, and a recirculation pump will take that water and pump it to that spray nozzles that's shooting up into the evaporator. But when the machine fills up, there's no float or safety that says, hey, there's too much water. So that water would overflow, like just about here, there's an opening that if the water gets too high, instead of overflowing and coming to the bin where the ice is stored, it's routed down through this hose into the drain. And if you saw the video, the guy says, oh, the hose is out. Well, why would the hose being out cause a problem? Anybody know why it would cause a problem?
Because the water would fill the bottom there.
Well, there's still a drain hole below the hose. So the thing is that the hose has to be in that opening or right at that opening. And the thing is that if it's out of that opening, yes, water will still drain out. But the ice that's stored in this bin, the ice stored in this bin would start to melt if that water got in there. Now, like the Whirlpool ice machine, these units are not like a freezer where, like, if you make ice, you put ice into a bin and it stays there until you take it out. These machines are constantly making ice, and they're like a cooler. Like if you buy a bag of ice and you go to the beach and you fill it up, you got ice all day, but by the end of the day it's all melted. Well, these machines fill up with ice. This piece right here, and I'll show you on the schematic how everything works, that's called the bin level sensor. So when the ice rises up and touches on this level here, it gets cold and tells the ice machine, okay, it's full, stop making ice. But they do not store ice like a freezer does. So as it's making ice will start to melt. It's normal. And the reason why they do that is because this holds about 50 pounds of ice. And the only time you really use that much ice, unless you have a family of 13 kids, or you got a party, that ice would get stale on the bottom because you as an individual would always be taking the ice off the top, and the ice in the bottom would never get used, so it would get old. Ice will get odors, taste, and other problems as well as mold. That happens a lot inside ice machines. Ice machines require routine cleaning, like taking it all apart, pulling this bin out, and cleaning it out. Now they do have some cleaning solutions that you put in ice machines and you let it run through. I prefer to take it out and hand wash everything myself, because the cleaning solutions will break up mold and stuff, but some stuff may not flush out the drain properly. So if you wash it by hand, you know for a fact it's all clean. So the ice that's built in here is called wet ice. Now, in a refrigerator, we might call it like a dry ice, but it's not like dry ice like, you know, if you put it in water, it bubbles and makes smoke and stuff like that. But that dry ice does not melt. This ice is constantly melting and always making ice. If you don't use that ice and you come back 3 days later, the ice on top is fresh, always. And the ice on the bottom may not be that old, but we want to continue to recirculate it. So this reservoir gets filled up, and I was talking about this hose, so it has no level control of how much water comes in. So if the water overflows or gets too much water in there, then it'll run down this delivery tube or overflow tube in the back. So let's go back here real quick. So you see these holes here. And the reason that is it sprays the water up, but any water that does not freeze falls right back into the recirculation bin here. But the metal has a second purpose. Anybody have any idea what this metal piece might do?
Does that melt any ice that would build up?
Well, we don't want to melt ice. So that doesn't melt ice. Any other ideas? And so when the ice falls out of the evaporator up there, it hits the metal plate and falls into the bin. That's why we have that plastic sheet. One, the plastic sheet keeps the water that's spraying up back in the bin, but the plastic sheet is not so strong. When the ice falls down, the ice can fall into the storage bin on the bottom. So that metal plate is to guide the ice out and not back into the water. Otherwise, it'll fall back into where the water is. So let's just take a look at the rest of this video. There's only like a minute left.
When you look up in there, it's kind of hard to see with a cell phone camera, but I got a good spray.
You can see the jets barely shooting up.
So, you know, we have to start suspecting that it's not cooling quite as much as it should. So, I come in and I pull the grate on the bottom, and you can see where I've already had it off.
What do you guys see there? Dirty condenser. That's the condenser. And remember, what does a condenser do? In a refrigeration system, you had a homework assignment. What's a condenser do?
It pumps the refrigerant throughout the system.
Nah, the compressor pumps the refrigerant. A condenser.
It condenses the refrigerant
From what to what?
from
Gas to liquid to
from
gas.
solid to liquid.
From a liquid to
I mean liquid to solid.
No,
I mean liquid to vapor.
vapor
Vapor to liquid.
to liquid.
Okay, I knew it.
Not solid.
I'm saying it's
It won't flow
solid,
through.
not
It's solid.
solid in there. Yeah.
Freon's always changing from liquid to vapor inside of a system. The evaporator, just think of the name evaporator. What does evaporate mean?
Evaporates from
It rained outside, we got a puddle.
vapor. Yeah.
And the sun hits it, the puddle disappears. Why?
It turns a liquid to gas.
It turns the liquid into vapor and it goes up into the air. That's what an evaporator does. As the water's heated, that's evaporation. And so the evaporator here is absorbing the heat from the water, and that's how it turns into ice. But the condenser has to release the heat that was absorbed by the evaporator, turn the Freon back to a liquid so it can go back up to the evaporator and do its job again. But if the condenser's dirty, are we releasing heat?
No.
No. Now that he may clean that, and that might fix the problem because the customer was complaining of ice production or low ice production. And if we have a cooling issue, if the condenser fan's not working or the coils aren't clean, that's going to cause a problem. But we could also have had a refrigerant problem. We could have a Freon leak or something like that where there's not enough Freon in the evaporator, so we are partially building up ice. Now, I haven't seen the machine, and I just found this video 30 seconds before this lecture, and it was more just to show you the water and how it circulates on the evaporator.
And I've got a coil that is pretty seriously stopped up. You know, the way I noticed that right off the bat was when you put your hand over on this side where you should be feeling warm air come out, there's almost nothing coming out of it. So I believe that's...
So when he's talking about the warm air coming out, is right behind this coil is a fan, and right behind that fan is a compressor, okay? So the fan's pulling the air in from here, cooling the coils in the compressor, but there's a back panel on there, and that's recirculating the air back through the front here. So let me just go ahead and switch this to my camera view for a second. Now if you look here, here's the front of our unit. Now my camera cord's so short I can't rotate the whole thing, so you're gonna have to see it up here on the screen. But if you could see here, this is our coil. And what I'm going to do is I'm going to take the camera and try to stick it in there so you can see the fan behind it. Give me a second here. And let me see what you're looking at.
Yeah.
I don't know if I can do it this way. I might have to turn the whole machine around. Hold on a second. I'm going to order a USB extension so that the camera doesn't have to be so close there. Now if we look at it from behind, you can see our compressor here. And the condenser fan, it's a little bit hard to see, but it's back in there behind the coil. That's the fan right there, if you could see that, okay? So that fan's drawing the air in. Now one of the good things is what do you guys notice from just this image that you can see right here? Something, I mean, remember, when you guys are technicians, it's not always with a meter you're going to troubleshoot the problem. We have to use our senses. What do you see there? Anything?
There's a compressor in front of the fan.
Yeah, there's a compressor, but do you see the condenser coil in front of the fan? You see these vertical lines there?
Yes.
What else do you see when you see the condenser?
Light.
You see light coming through.
So it's clean.
So that one's got a good airflow just by looking at it, right? So his one that he's showing you in the video doesn't have that airflow, okay? So let me just put my camera back. So let's go back to this video just for a second to see what else he has to say.
The issue with the ice maker, it looks like it to me. I'm gonna give it a good cleaning and see if it won't go back to working correctly. Thanks. All right,
Wow, that looks great.
I've cleaned it. And I removed the front cover here, so you could actually see that I cleaned it all the way back into the back.
Yes, it does.
I cleaned it back there, got all the front cleaned off nice. It looks really good. That ought to work well. Fixing to assemble it again and turn it on and see if we can watch it make ice.
Okay, as technicians, we want to make money, right? And the only time a customer is going to call us out is when something breaks. But on an ice machine, as a technician, you tell them, look how dirty this coil was. Should be routinely cleaned once a year. And I would sell them a cleaning, not just the coils, but clean all the components of mold or whatever inside the unit so it stays like this. Now you're like customers that say, well, I don't really, why should I clean every year? I don't want to spend that kind of money. It's working. But here's the thing. If those coils are dirty, what problem will arise from dirty coils?
Bad airflow.
Bacteria in there.
Not bad bad airflow, but a little bit more. What were you saying?
Bacteria that will accumulate in your ice.
No, because this is outside the unit. This is here on the bottom of the ice machine, right here in the front. The ice never touches this or even gets close to this. But it happens to the refrigeration system if the condenser doesn't have proper airflow. What would happen?
It's not gonna get colder.
It's not gonna produce,
No, that's not what I'm looking for.
it's not gonna produce ice the way which it should be, it's not gonna be.
Yeah, that's what the video is about. Okay, but this is what I'm talking about the refrigerant in the system. What did we just say happens to the condenser? It turns
Turns
Vapor to
vapor.
liquid.
vapor to liquid. Okay, so refrigerant works on temperature and pressure. It's important, the right temperature and the right pressure, or we're not gonna get refrigeration, cooling, ice machine, whatever you wanna say. This is just a refrigerator. That's all it is. I don't look at it as like, oh, it's an ice machine. I fix refrigerators all day, but it's an ice machine. I don't know. Except for the electrical circuitry, it's got a compressor, evaporator, condenser, just like any other system. But we need to release the heat. If we don't release the heat, the compressor running hot, heat is going to raise what? If I have more heat, what am I going to raise? Pressure. Okay? So normally on a refrigeration system with 134A, we run about a 0 PSI evaporator. We run about 120 to 130 high side pressure, condenser pressure. But with the coils being dirty, we're going to raise that head pressure, which is a term we use on the high side. Okay? If you raise the head pressure, you're putting more stress on the compressor because it's trying to pump into the condenser, but now I've raised the pressure of the condenser, I put a strain on the compressor. And by not releasing the heat properly, what happens then is compressors are like car engines. They have a little bit of oil on the bottom of them. And that oil may turn to vapor in the excessive heat and flow through your system and cause a problem with your refrigerant system. So you tell the customer, listen, you see how dirty this coil was? If we go back to, his dirty coil, you see how dirty that coil was? Yeah, you might say, oh, well, I'm gonna have to pay for a cleaning every year. I don't know if I'll spend $120, $150 on the cleaning. Hold on one second, guys. There's someone out there. Anyways, going back to this though, so you can tell them, listen, not only can you get mold and stuff in your ice, which means it needs to be routinely cleaned, but not cleaning the coils and stuff is going to cause a refrigerant problem or a compressor failure in the future, which is going to be a lot more expensive than if they pay $100, $120 a year just to keep it clean. These units are about $1,000 to $1,500 a piece. They're not cheap for such a small machine, okay? So telling them, listen, this is what's gonna happen if you don't keep it maintained. Now, maybe you can go without a washer doing a routine maintenance or service. I remember one student, and I ain't gonna mention his name because this was 25, 30 years ago. He told me he's gonna sell a customer a checkup on their stove. Like, I'm gonna do a checkup on their stove. So, how much? Oh, I'm gonna charge them $80. Now, this is back 20, 30 years ago to do a checkup. Well, what are you gonna check up? Well, I'm gonna look at the wires. Okay, the wires are there, yeah. I think the only thing I could think you could do is maybe oil the hinges or something, or maybe check the temperature in the oven. But what, you want to sell it routine maintenance for not vehicles, for appliances that could use it. A dryer could use a routine maintenance, cleaning the lint out, making sure the ventilation's good, because it could break down. But a dryer is only $400, $500-600, except for the real high-end ones. But these machines here, a lot more costly and a lot more work to change a compressor on one of these.
So I say maybe like for commercial appliances,
Yeah, and believe it or not, a gentleman walked in here yesterday asking about ice machines. And I said, well, we teach ice machines, but we don't teach the big commercial ones. And he was a little bit like, oh, okay. But, you know, if you understand how these work, you can work on commercial ones. Those you guys that were here in the class, remember, I think the one we fixed was a Scottsman, the one that we took out of school cafeteria, and
Oh, yeah.
Gene recharged it, and
Yeah.
we fixed a commercial 500-pound ice machine.
Yeah.
It's just a compressor and controls. If you understand how the refrigerant system works, now you just gotta understand how the controls work, okay? And by the way, that machine's still working. So, let's go to the schematic I have here. Oh, this one here. For some reason that touchscreen does not work. So here's the schematic. I know it's a little bit hard to read. Can you guys see that from a distance? So,
See it.
So.
I can't see it.
yeah, I can't make it any darker. That's the way it was in the service manual.
I watched the video and
Yeah, but even the video is a little bit hard to
be able
to see it. I don't know if I can move this closer to the thing and get maybe a little bit better quality of video on it. Let me see this here. Okay, so these two diagrams are the same. We have a schematic and a pictorial. Pictorial is more pictures of the parts. Schematic breaks it down into simpler circuits that we can follow through and travel through the current is flowing through. Excuse me. Let's go ahead and take a look at this one on the bottom, and let's talk about its operation. Now, let me see here. Now we have to read this note here, and let me move this out of the way. It says this unit is shown in the timed portion of the freezing cycle with the drain pump in operation. Okay, now first of all, drain pump isn't even shown here. We have another model that has a separate drain pump. That drain pump is also known as like what we call condensate pump. They use them in central air, that if someone has an air conditioning system, let's say you have an older home, and the only closet you have is in the middle of the house, where you're gonna remove that closet, put your AC in there. Well, the AC collects moisture and it has to have a pipe to drain to the outside. If you don't have a way within the center of your home to run a drain, they have a separate little box that has a float in there and a pump. And when the AC drips water into this box, the float rises, and when it gets to a certain level, hits a switch like a float in a toilet bowl. It hits a switch, turns on the pump, and it has a second switch. When it drops low enough, it turns the pump off. Now you have to run a pipe, but the advantage to one of those is that these machines are designed to be what they call gravity drain. You have a drain in the floor, or you have this attached to like an exterior wall of your home. You just drill a hole and run that hose outside and let that water drain outside. But if you do not have that ability, you have a condensate pump that would be built into the machine, and it would pump it out. You could go up into the attic and run it all the way across the house, and the pump would mechanically pump that water out. You don't have to use gravity to drain it out. Now, our ice machines, the Whirlpool ones, have that, but the other thing that they have, as I said, when the float rises, it hits a switch to tell the pump to drain, and it goes down and hits a second switch to tell it when it's low enough. But there is a third switch that the pump goes like this and hits the pump and tells the pump to run. Let's say the pump is stuck or doesn't work. The drain hose is clogged up, or it's all dirty, or the pump is bad. It's going to still drain with more water. Then it goes a little bit higher the float. It'll hit another switch, which will completely disable the ice machine at that point, so it doesn't flood the customer's house. I'll show you a different schematic that's going to have that pump in it, but ours doesn't, so that's why I don't have that one up. But if we look at this book here, let me go to the other diagram just to show you how it would be inside. Here's the diagram here, and this is if it has that pump. Has a drain pump with a switch here that tells it to run the pump motor, but it has a kill switch there. In case it doesn't pump out, it will then stop the whole machine. It'll stop power from coming everywhere inside this machine. Now, we don't have that model, so I'm not going to go over that now, but if you want to know how a condensate pump works, look at our Whirlpool machines, and it plugs into the actual machine. It doesn't have its own power supply. It uses the power of the machine. Plugs right into the bottom of it. Now, on the Whirlpools, the older ones, there was a jack up underneath the unit and had like a little clear plastic thing that if you didn't have the pump, you had to have this little plug inside that opening because that would bypass this switch here so the machine would run. So if that was ever removed, the ice maker wouldn't work. So that is if you don't have this drain pump. But we're gonna go over this one here. So if we look at this schematic here, this is actually in the ice production cycle. Let's first go ahead and just break down the components, and then I'll talk to you a little bit more about that. So power comes in here. We have the bin level control. That was what I showed you in the video. I said, you saw that little bar that was inside there? That is a thermostat type control. I'm gonna turn this around so you can see it. Let me go back to the camera. I'm gonna get I got a wireless mouse that I can control without having to go here every time. So if we look at these controls here, and I'm gonna go ahead and open this up for you. We have two thermostatic controls here, one here and one here. One is the ice thickness control, and the other one is the bin level control. And I'll show you and explain to you them in a second here. Let's go to the diagram and look at those two thermostats on the diagram. So, no, wrong one. This one here. So that was the bin level control, and if you see that little symbol like this, and then a switch, that means it's a thermostat. We have another one over here, which is cube size control. And that is the dial that's in the front here.
Q size?
Cube size.
Cube size.
I'll go to the camera. There's a dial in the front here, and I'll show that to you. That is a thermostat that has a tube running all the way up to the evaporator where the ice is made. And when you adjust that cube size control, it's sensing the temperature of the evaporator. So once the ice gets a certain thickness, it knows to drop the ice. Okay? So that's the cube size controlled thermostat, the bin level controlled thermostat. Now, both thermostats we have here in our unit. How do I know which one is the bin level and which one is the cube control? Look at the diagram and tell me what can you see looking at the diagram which would tell me just by looking at the part, oh, this one's the cube control and this one's the bin level control. What is it on this diagram that's going to identify that to you?
So there's a location where it's set at?
Not location, just look at the schematic. What can you see are different between the two, the way they are wired in the wiring diagram? Trying to get you to read the diagram. Yes, sir.
The cube size control is attached to that switch. Was it a double pole switch? Is that
Single pole, double throw,
right?
okay? So what does that mean, single pole, double throw? What am I looking for?
It's a contactor?
I'm sorry?
Contactor?
Not contactor, but contacts.
Contactor.
Or were terminals where we'd have wires.
Right.
How many wires are connected to that component?
It's only three.
3. We got one here, another one here, and another one here. So we have 3 wires on that, right? What about the bin level control?
2.
It's only got 2 wires on it, one here and one there.
Right.
Okay, so if I go to the camera, which I gotta get this board recalibrated because I can't use the bottom of it. If I go to this camera, I can look here and I can see that this one on this side here has 2 wires. Can you guys see that?
Yeah.
And the other one, a little bit harder to see, but there's 1, 2, and another one back there, 3. So this one is the cube thickness control, and this is the bin level, right? Okay, so that's those units right there. So they're just regular thermostats. If you looked in a standard refrigerator, like our Frigidaire top mounts units, let me see, I think I have one where the controls are out. Give me 1 second. So I'm just gonna put this up on the camera here. If you look at this part here. That's a thermostat with a capillary tube running all the way here to the front. That's just a 2-terminal thermostat, just like the bin level thermostat. It's the same thing as a refrigerator thermostat. So it looks exactly like these, doesn't it? So both of them, they have these capillary tubes which are running through here, and those capillary tubes are either filled with a liquid or a gas, and when it's heated or cooled, that gas expands or contracts, which cycles the switch. And that's what these little bellows are. There's a little diaphragm or disc there that when expands or contracts, pushes an actual switch contact. Switch contact is inside this ceramic piece, and it has a lever there that's pushed by that capillary action. Okay? So that is that. Let's go back to the schematic and identify what is going on with this unit. So let's see what's energized here. Power comes in, line 1, goes through the bin level control, goes to this component and out. What is that? It says it right there. I know y'all can't see it.
Control board? Compressor.
Compressor.
Oh, I can't see it all.
You guys can pull up chairs and sit closer. You can all sit right here if you want. But that's the compressor. This is the overload here. These are the run and the start windings, RS. And this is just the relay and overload. But that's just the compressor. When does that compressor shut off? The only time that compressor shuts off is when the bin level control opens. So in other words, when the ice fills up the bin, the compressor shuts off. So that means 90% of the time, this compressor's running. Not just in ice production, but ice ejection. What does that mean? Ice production, ice ejection.
Ejected out of the
Yeah, so then the water sprays up into that evaporator and freezes up in there. Now we need to get the ice out. That ice coming out would be, we call ice ejection. The compressor doesn't shut off from ice making to ice ejection, but something else happens, okay? We'll talk about that in a second. But the only time this compressor will shut off is if I unplug it or the bin fills up and that little sensor I showed you at the beginning says, hey, we're full of ice, stop making ice, and then the compressor will stop. Once the ice melts on its own or a customer uses ice and it drops, it'll come back on again. All right? So when that comes in, power comes here, goes through our compressor. And I'm just gonna go real quick through there. And then we go here, we have a timer switch. Again, this is in ice production mode according to the instructions here. So this switch is inside of a timer. Here's the motor that's running that timer, and it goes to the spray pump and the fan motor. Well, the spray pump is located right back here. It's right up here, and I'm just gonna move the camera so you can see it. It's this component right up here, and it's down inside that reservoir that I showed you at the beginning of the video, that little triangular reservoir, and that pump is taking the water and spraying it up through those jets. The water falls back down, so it's constantly recirculating that water. Now, if the water valve is bad and not allowing enough water to come in, you could be halfway through ice production and then there's just no more water circulating. The machine doesn't have any flow or device to say, hey, we're low on water, give me more water. The water is a timed fill. Based on this much water pressure, they go a little bit over in the time. So in other words, if it takes a minute and a half to fill, they'll run that water valve for like 2 minutes. And that's what that overflow pipe was for. Okay? So this is our recirculation pump here, and you have to access that through the rear of the unit. So let's go back to the schematic here. So while it's running, the other thing is the timer motor. So the timer motor is running. Now, as it's running, the hot gas solenoid and the water solenoid, those two components are not working. I'll explain to you what the hot gas is in a minute. But this is The only three parts that are working besides the timer motor, that's it. So a customer calls you out and says, I don't have no ice. During ice production, we're only looking for three parts working. The compressor, the spray pump spraying the water up into the evaporator, and the fan motor. That's it. What fan motor are we talking about?
The evaporator, what was across the evaporator?
We don't have an evaporator fan. What fan did I just show you? I just took the camera in there and showed you guys a fan.
It's off that compressor.
Condenser?
What is the condenser fan? That's the one on the bottom. It does not have a fan up there. Because fans, like in refrigerators, are used to circulate the air in the entire box and cool the box. At the beginning I said, this thing here is not meant to hold the ice forever. That ice is constantly melting. We don't refrigerate this cabinet to store the ice. So we have no fan here circulating the air. It's just the evaporator itself is so cold, the water sticks to it. That's it. We're running at 15 degrees below zero in the evaporator, just like a refrigerator evaporator. And the water hitting it is going to, every time it goes up, it's getting cold from that evaporator. So if you put your hand in the water at first, it'd be room temperature. But as it's circulating through, it's getting colder and colder. You stick your finger in there, that could be 30-degree water. Now it won't freeze if it's moving, but once it throws up onto the evaporator to 15 degrees below zero, that's another 40-degree colder. And that's going to stick there, and that's how the ice is produced. So once the ice production is done, we have here this cube size control. And I'm going to say, okay, the evaporator said, hey, the evaporator's filled with ice right now. We're ready to drop ice. We got the size cubes we want. This thermostat is going to switch from 2 to 3. If I switch from 2 to 3, then there's no power here. That doesn't affect these components, does it? No. What affects these components is when it's running, power goes to the timer motor. The timer motor will then switch this switch over to here. On average, these ice machines take 20 to 30 minutes to produce ice. And they were running it the other day and said, oh, I need to close the door. No, you can run an ice machine with the door open and watch it. Again, it's not a refrigerator or freezer where the air in the box freezes the ice. It's the actual evaporator. When the water touches it, it makes the ice. So it doesn't matter if the door's open or not. Will it affect it a little bit? Maybe a little, maybe half a minute or so. But the timer will run for about 20, 25 minutes. I don't know the exact time. I'll have to look at the manual. And it'll close this switch. When it does that, the pump stops spraying water and the condenser fan stops running. Now we energized the water solenoid and the hot gas solenoid. Our cube size thermostat will switch over here, and then the timer will continue to run. So let's go back from the beginning and explain this cycle. I'm just going to go over here, not the compressor. It's running, the fan and the spray pump is running, and the timer is running. We're in the cooling cycle, right? Timer runs for 20-25 minutes. It then cycles this switch over, turning these parts off and turning these two parts on. But when it switches over, the timer is still getting power. Now we're pumping hot gas into the evaporator. At that point, our control switch here will close, feed our timer motor so that the timer motor can go back into ice production. Okay? And then at this point, the switch will drop back down and the timer will run through its regular cycle. So we turn on these components, and then when we're done, we turn on these two and turn these three off. So what is a hot gas solenoid? Anybody know? Well, let's take a look at a refrigerant system. You have a compressor that pumps Freon into the condenser. And then it runs through a metering device. And I'll explain that in a second. Then it goes over here to the evaporator. And then returns back to the compressor. That's the cycle. Compressor, condenser, capillary, evaporator, back. That's cooling. Now, we added something called a hot gas valve. So right here on the compressor is a second pipe to a magnetic coil called a hot gas valve, and that coil connects to here. Now what happens in a regular refrigerant system, it's pumping into the condenser, it's pumping, it's pulling the freon from the evaporator and pumping it over here. But if the pipe's all the same size, as soon as I pump, it just goes right around. So the metering device is usually a capillary tube, a real skinny tube, like 1/10 the size of all the rest of the tube in the system. So as the compressor's pumping here, it can't get back to the evaporator as fast as I'm pulling it out, and that's where the two pressures, the evaporator goes down and the condenser goes up, high pressure and low pressure. But we want to remove the ice. The evaporator, I told you, is negative 15 degrees. Well, if it's that cold, the ice will never fall out. I gotta warm it up. If I use a heating element, it might be too much heat and make it hard to remove. But when a compressor pumps the freon, it raises the pressure. What did I say at the beginning? When you raise pressure, what are you raising? Temperature. Okay? So when it wants to drop the ice, we energize this coil, and the freon bypasses the condenser and goes right here to the evaporator, warming it up. It's pumping it in there, raising the pressure up at this, and that's what causes the ice to release and fall out. And that's where that evaporator thermostat or the ice cube thickness thermostat will cycle it one way or the other. Okay? That's how the ice is ejected. Now if we look, this is a pictorial of this diagram. It's a little more confusing to read, but we don't really use that for troubleshooting. What it does is, if you notice, we got L02, L05, L03. Those are places where wires connect. I'll show you in a second with the camera. I'll zoom in on that. But I don't see colors. The colors are in my pictorial diagram. You can see black, blue, black, black, blue. I can see on L05 I have 1, 2, 3 red wires going to that terminal, and there's one other wire here, black, that are, no, that's not the black one, I'm sorry, I followed it wrong. It's this one right here, this wire right here, which is red going to the compressor. So that's just a terminal board where they connect multiple wires instead of using like a wire nut to connect them all together. Let's take a look at this. Now if I lift this up, or let me just lift it to the side here a little bit, you might be able to see right here, it's upside down, but it says L02. Can you guys see that? Right there?
Yeah.
L02. So all these wires connected at the very top here are L02. What does it say over here on the right? Can you see that?
L01?
L05.
This is blurry.
Can you see it? Hold on. Let me see if I can get the thermostat's in a way. Let me move the thermostat over some, move the wire down. Can you see the L05 now? Right there? And then L01 is the terminals below it. All that is, it's not a circuit board like you would think a washing machine or dryer computer board is. It's just a board where all the wires can connect to instead of using wire nuts. If you had to change a part, you just unplug the wires from that part and put that up in there. So that's just a connection board. But we have two thermostats here, and right here on the right hand side is our timer. Let's take a look at our timer. The timer here is just like a regular dryer timer motor. I can rotate this dial here, and right there is the timer switch. You guys can see that there. What type of switch is that? It's got how many wires? 1, 2, 3. So if we go ahead and take a look at the schematic.
Single pole, double throw.
Single pole, double throw. We look at the schematic here. This timer switch is single pole, double throw. But, I'm sorry, I'm on the wrong, no, that's the timer switch, single pole, double throw.
Yeah.
I'm on the wrong part.
The first.
Single pole, double throw timer switch right there. So the two thermostats is this one and this one, but they're single pole, double throw. It's important that you wire up these components right. If you look, we got common, normally open, normally close. I'm gonna zoom in on this one so you guys can see it a little better. Common, normally open, normally closed. Let me make it a little bit bigger for you to see. I know it makes it easier to read, but I can't show the whole diagram. If we look at our timer switch, common, normally open, normally closed, I could look at it and say, okay, my red wire is on common, my blue wire is on normally closed, and my orange wire is on normally open. And on the switch, right next to each terminal, say COM, NO, and NC. Okay, I have people that take parts off of machines and they don't look at where the wires go. They sometimes take pictures, which is a good thing, but sometimes I take pictures and the colors don't show properly either. Got to learn to use this diagram here. I wouldn't use this diagram for troubleshooting. I could do it. If that was the only diagram I had, I could troubleshoot the machine with that. But it's a little bit harder to follow the circuits, where this one's a lot easier, and this is how we use it to trace. But if we can look here, look at all these L02s, all the way over to my timer motor, all go to L02. Well, I still don't know what colors it is, but coming off the compressor, which is what this is, I could go in here and say, oh, here's my compressor, and if I follow this one, this goes what, to L02, and the wire color is white. So I could say, okay, this one's white. This one here, the spray pump motor, where's my spray pump motor? Here. And L02 is here. That's a black wire. So this one's black. And the thing is if you can't read the diagram, you would see a black and a white wire on the same terminal. You say, wait, that's line one and neutral, it's gonna short out. No, that's the color. But you have to make sure, because there's more than one black wire. So you have to make sure that that black wire connected to L02 is that part. But you know it's a black wire. What's the fan motor? Can you guys tell me what color that fan motor wire is? Fan motor goes to L02. So first thing you want to do is look through here and find the fan motor. Can you find the fan motor?
It's black. Oh, that's the timer. Sorry.
Right here. It is black.
Oh, yeah, okay, all right.
Okay? And then the next one is the water solenoid. Where's my water solenoid? This is the water one. This is the hot gas solenoid. One is for water, one is for the refrigerant. And then one side of the solenoid goes to L02. What color is that? Blue. So that terminal has blue, white, black wires all in the same connector. That's the way it goes, okay? How about the hot gas? It has a black going there. So that's the fan motor was black, the water solenoid was blue, and the hot gas solenoid was black. And then we got the timer motor, which is also black, going to L02. So we got 1, 2, 3, 4, 5, 6 wires. 1, 2, 3, 4, 5, 6. Before you can troubleshoot these machines, you got to be able to see these things.
Black and blue.
Because I know Gene's going to be mad at me tomorrow when he comes in.
Uh-oh.
Because some wires might happen to fall off the connections.
Uh-oh.
And I'm not going to allow him to use a camera and pictures to rewire it.
That's schematics?
He has to use this.
Wow.
You want to learn how to do this. This is how you're going to do this. I'm going to pull these wires off and you're going to rewire. Now, I know I didn't go over the whole machine. I went over basics of the machine, the basics of the schematic. Now what I want to do is, Gene's going to reconnect this up to the water supply and everything else. And once he's ready, I want to call you all over there and let's just watch the ice cycle and watch actually the components in operation so that you can actually see how it works. I don't want to get so deep into it and you never even seen it run yet. So I might add a little bit more lecture tomorrow, a little bit more deeper troubleshooting. And we'll go into a little bit more deeper on the components, what they are. I'll break each component down for you. We'll pull them out, we'll look at it and so forth. Now I have a second thermodor that will tear apart. We'll take all the parts out and look at the physical parts so you guys can see them. How do you replace it? You know, how does it look inside the machine? How do you service it and stuff like that? And we'll do a tear down of that ice machine. Any questions on this so far? No? Okay, so then we'll have him connected. When he's done, I'll just have you all gather around. We'll just sit for a little bit, watch its operation, and we're going to listen to sounds and hear sounds that are cycling. What is that noise that I hear? What is that part that's running? Troubleshooting is, again, I walk up to a machine, I could just look and say, oh, this is what's wrong, because I know how it's supposed to look. You guys don't have to memorize everything, but there's sometimes you could just say, that just doesn't look right. The other day, Ms. Z had the stove, and the stove was blowing a breaker. Now you had all these switches on the back of the stove. I didn't even look at the diagram, and I looked at each switch and went like this. I said, that switch is wrong. You got line 1 and line 2 connected on the same terminal. I didn't even look at the diagram. But I'm talking about 5 or 6 switches with 7 or 8 wires on all the switches. And I just looked at it and said, that looks like your problem right there. I mean, the more you work with these and the more you see how they're connected and understand how they work, the easier it is for you to understand how to troubleshoot it. This is why you guys are constantly tearing things apart, putting them back together, testing components. Use your schematic. Okay, that's important. We got to constantly test them, find out how to remove them, and then find out what they do. Watch how they work. Listen to the sounds they make. I could walk up when you're working on a washing machine and listen to different parts and know what's running right now just by listening. You guys don't have to memorize all that stuff, but get familiar with different sounds. Say, oh, that's the actuator on the washer shifting from one cycle to the next. Well, that's a drain pump that's running. Oh, that's a water valve that's running. I know those sounds. Familiarize yourself with them. When you're told to plug them in and test them and run them, listen for that stuff. Because when I go to a customer's house, I turn the machine on, I'm standing there talking to a customer, oh, you know, this is what it's doing and everything else. But really what I'm doing is I'm listening to the machine over here while I'm talking to them. And I say, oh, 1 second, ma'am, I hear something that don't sound right. And I start troubleshooting. I don't know how many times a new product came into the market, new design or whatever. I walked up to that machine in a customer's house and said, I've never seen this before. Dang, I don't even know how to open it. Now I got to troubleshoot it? Okay, well, let me just look at it. And I start looking at it, and I said, oh, I'm going to check this or I'm going to check that. And immediately I start putting 2 to 2 together, and I troubleshoot it. I'm like, wow, you know, sometimes I pat myself on the back. I got it. But it was like, test what I know how to test to try to find your problem. Okay? So we're going to watch this thing produce ice today, and then we're going to do a tear down of this machine tomorrow. So I didn't put it on there. It's going to be a lecture, but guess what? It's going to be a lecture. Okay?
Okay.
Any questions? No? All right, so now you guys want to see this thing in action.
Yes, sir.
Now you do have this manual in your refrigeration folder under standalone ice makers. This is the Scottsman DCE 33.
Now you tell us.
Now I tell you?
Yeah. I couldn't see the whole the board. I'm squinting at me.
I'm sorry.
All right, we got this.
But now I told you.
Yeah, at least now I know.
And which one is it? The Scottsman DCE 33?
Yeah, there's 2 books in there. This is the 33. Now remember, even though it says the 33, when we look at this manual here, I'll show you what the manual looks like in the front cover. The DCE 33 service parts. This goes through the whole thing. It gives you a breakdown of every component in this ice machine, as well as the schematics. There's a second book here in your drive, let me go back to the refrigeration folder. Man, I can't see it either. So there's a second folder in your drive under refrigerators. And we go standalone ice makers, and I'm gonna go Scottsman. There's a 33M and a 33P. I think the one I had was the 33M, let me see. So this one here is the one that actually breaks down a little bit more detail of what all the components are doing within the ice machine. How to install and connect. And then we get a little bit further down here. This is showing you the actual system here. If you look here, here's your hot gas valve. Remember I said there's a hot gas valve? So normal refrigerant flow comes from the compressor into the condenser. From here, it goes up to the capillary tube. You notice how small this is compared to these two lines? It's actually drawn smaller on purpose. That's your capillary tube coming off your filter. And then it goes here into an accumulator, and then it goes into your evaporator. And then after it comes back out the evaporator and comes here and returns back to the suction line here, back into the compressor. But when we want ice to release, we energize this solenoid. Instead of Freon coming here, the Freon goes this way, right to the evaporator and causes it to get hot. So that's what I was drawing for you on the board there. So here's our water circulation. We got our recirculation pump here, which sits in the water, and the water gets pulled in, the pump pushes it back out and up through the jets. They shoot up into the evaporator, and then the remaining water falls back down and continues to recirculate there. This is our water valve here in the back of the refrigerator. This is when the ice machine wants to fill with water. It comes in, goes here, and fills up our reservoir here. It doesn't go to the evaporator. Even though you see it up there, it's not going to our evaporator there. So this is on your book. and showing you the ice machine clean the condenser, just like the video I showed you. And so here you can just see here, allow the ice machine to operate for 2 hours. We're talking about cleaning it and maintaining it. Remember I told you to sell them a service? Cube ice adjustment. Okay, and adjustment of the timer. So that timer is a more solid state timer. The one that we have on ours is a mechanical timer. It has a regular motor like a dryer timer motor, and it has a little switch like a microwave door switch on the front. This is a solid state timer. You can actually change the times that it actually runs in cooling and ice ejection. And then these are the switches here. 2 are power in, and the other 2 are controlling that single pole double throw switch there. So you can find that. Again, this isn't exactly your model because it has that solid state. And the nice thing about this is it tells you if you're having this type of problem, like here, no ice is falling in the bin, but the machine operates. The ice is not falling down. These are the things to check. It's possibility and things to check. So this is your diagnostics as well. Here's your water valve. I ordered the plastic sheet, the exact one for this machine, because it just had a flimsy plastic one we made. So hopefully that'll come in. This is a little bit more about the timer. You guys can read all that, the bin thermostat. So all those components are there. And check that out. All right? All right. I'm going to end that for now, and then we'll do another video tomorrow.